Disease detectives are getting better at connecting the dots when it comes to food poisoning outbreaks. Historically, outbreaks are detected when illnesses occur in a similar time or place, like in a town where customers get sick one weekend after eating at a restaurant. Investigators would go out and ask what they ate before they got ill, then compare notes to see what food everyone had in common. But this method could miss cases. It could miss whole outbreaks when illnesses were scattered over time or geography. Food poisoning investigations took a huge step in the 1990s when scientists started looking at chunks of a germ's DNA. The technology wasn't perfect, and it sometimes failed to connect related cases. But now, investigators are looking at all of a germ's DNA. That's called whole genome sequencing. It lets them compare the DNA of germs taken from different people to see if they're the same, and they can find how resistant the germs are to current medicines. In 2013, U.S. scientists started using DNA sequencing to investigate outbreaks of listeria, which is caused by bacteria that spread through contaminated food and can be deadly. One of the first success stories happened around Halloween in 2014. Listeria cases began popping up in Arizona, New Mexico, and the Midwest. Scientists saw the same DNA sequences in bacteria taken from 36 people who got sick, suggesting they were all part of the same outbreak. But what was the source? Patients and their families didn't mention hot dogs or deli meats or other foods commonly associated with listeria, but most did say they had eaten packaged caramel apples. Scientists hadn't considered caramel apples a threat, but it turns out that putting a stick in a caramel-covered apple gives germs a door into tiny spaces between caramel and the apple's skin. Most of the detective work using whole genome sequencing has been focused on listeria so far, but it's expanding to other, more common causes of food poisoning outbreaks like salmonella and E. coli. Most of the testing has been done by the U.S. government, but all 50 states are getting money to help them set up their own labs using the technique. It's a little too soon to call it a success, but this new way can help identify common causes in seemingly unrelated illnesses and detect outbreaks more quickly and more cheaply.